Hello, everyone. My name is Elika. I'm very glad to see everybody here. And I'm a PhD student of computer science. I'm a graduate student, and this is the third year that I'm at UGA, and first semester that I'm serving as the chair for the publicity and communications group. Do you all have any questions for me? All right. So as I can see, we're supposed to talk about GIS and Imagery here. So we have Dr. Lowe and Dr. Bernardes and Caroline. I was just wondering if Caroline wants to go first, or
Sure, I can do a brief intro about myself.
Of course, thank you.
Yeah, no problem. My name is Caroline Narron. I am a fourth year PhD student at UGA. I am with the Department of Geography, specifically advised by Dr. Deepak Mishra, who is the director of the Remote Sensing and Spectroscopy Lab, which I'm a part of. So happy to be here today with y'all.
Thank you. So I'm asking Dr. Lowe to go ahead.
Oh, good afternoon. My name is Tripp Lowe. I work at the Warnell School of Forestry and Natural Resources. I have the opportunity to teach a handful of classes. We teach an undergraduate GIS course where the students focus on fundamental methods and applications in GIS.
Okay.
I get to teach a graduate level course where we primarily focus on applications of GIS for forestry, but we have strayed into some of the water issues as well. And then in the spring, I have the opportunity to teach the drone class, where we spend half of the time focusing on the Part 107 regulations, with the hopes that once the students graduate, they will have an easier time passing the Part 107 exam. And the other part of the class, we focus on processing the drone data and analyzing it for the different natural resource problems.
Perfect.
And I want to highlight a couple of well, I want y'all to know that our undergraduates are or have the opportunity to use these emerging technologies in real life circumstances. We have GPS units that can take you back to where you've been for within a couple of inches, and have teeny tiny drones that we can fly down the hallway to bug our neighbors. And our latest acquisition is an autonomous surface vehicle, a water drone. And we've had students up in North Georgia doing bathymetric mapping in a lake that they were considering reverting back to a wetland, and graduate student working in the coastal creeks along Georgia, or the coastal Georgia, working in the Georgia coast along the creeks, mapping water flow. And even a student trying to look at biomass of hydrilla. So I asked one of our undergraduate students, Jordan Horvieth, to come in and just talk just a little bit about some of her recent experiences, and it has been it's actually a big deal. Jordan, I will relinquish the microphone. I'll put myself on mute.
Hey guys, I'm Jordan. So
Okay.
I took spatial analysis with Dr. Lowe last year. So that's one of the classes that's offered by Warnell for learning GIS. Now we're applying the GIS tools that we've learned in our, everybody in Warnell has to do a capstone project of sorts. We call it a senior project. Some people write a thesis instead if they're trying to go to grad school. But I've chosen just to do projects. So I work with a group of students. There's 2 other teammates. And we recently, we've been assessing a landowner's property for basically what opportunities are available terrestrial and aquatic wise. And so we use the autonomous surface vehicle to measure. Well, we measured discharge and in the stream, and we measured the we pretty much got a bathymetric survey of the whole stream. And there's a dam there, so we took the measurements of the dam to see how it affected, to try to apply how it will affect the aquatic species present. We also shocked fish, and we found a new to Georgia invasive species. So we did backpack shocking, and that's where you have, just this huge backpack that sends out an electrical current, and it will stun the fish and they'll float to the surface. We net them, and then we count our species. And we found a new species called a weather loach there, and it's from Asia. It's a common a common aquarium fish. So we think that probably somebody dumped their aquarium fish there. So now we are going to go out and do continuous shocking to sort of try to find out how many are there, how bad is the problem, are they really going to, are they going to outweigh the natural or the native species that are present there.
And Jordan,
So,
to put a follow up on that, the important part of this whole exercise is the students have gone out and collected data. There's information in hand. Now they get to come back and map this information out, and not only look at the information in tables or spreadsheets, they get to look at it in a spatial context. And I think that is the important aspect of our application here at Warnell of GIS.
perfect. So do you work in a joint program, like working with computer science or any engineering majors here at UGA to helping you with the applications and system that you talked about, like measuring stuff or other things?
I've had several students from across campus in the courses, and we have collaborated with geography quite a few times. There is certainly room for collaboration with the computer science folks, just with the volume of data and the opportunities for the machine learning applications.
Sure. I see. I can see Dr. Bernardes is here. So could you please go ahead and introduce yourself, please?
Yes. So I'm Sergio Bernardes. I'm the Associate Director for the Center for Geospatial Research. This is with the Department of Geography. We've been there since 1985. In fact, under a different name, but always working with GIS, remote sensing, strong components in geospatial analysis and understanding the environment. A lot of work with federal government and also academic work and research. My background is in fact in agriculture and with remote sensing and then geography. And I worked in the industry for a while and also with the government, and then came back to academia. do a lot of work with remote sensing from orbital. Scale is something that we geographers would like to explore in different scales, from orbital to very proximal remote sensing using drones, but drones sometimes they are not close enough. So we are mounting systems. So one of the examples is even hacking Kinect sensors and using Xbox Kinect as a way to collect data. Our augmented reality sandbox, and so we do GIS to remote sensing, but I'm also very interested in geovisualization. We are collecting a lot of data these days, but how do we visualize this data, and how do we extract information from this data? This is the big challenge now. Not so long ago, we were begging for data. Now we are flooded. So how do we process all this stuff, and how do we make sense of all this stuff? So geovisualization strategies are extremely important, and we've been exploring those with augmented reality, virtual reality, among other technologies. And unfortunately, traditionally, GIS Day is a day people play with the sandbox. Unfortunately, this time we couldn't do it, but we are thinking other possibilities. We have one project on the way that involves porting some of those technologies to mobile devices and allowing people to experience augmented reality using their phones and tablets. And this is collaboration, involves computer science, involves engineering, involves psychology, a strong psychology component, by the way, and perception. So when I mentioned geovisualization, we think about the numbers. Psychologists think about the brain and how the brain sees numbers. So one of the things we just put together is different ways people see color and replicating, mimicking the efficiencies in color perception. And this is a filter that's going to be available to people on Instagram. And this, we've seen a lot of maps using a lot of colors that perhaps shouldn't be there. So that may help with putting maps together. Putting together an augmented reality globe that is allow people to interact with planet Earth. And this is going to be a floating planet Earth. It's going to have different themes. You can choose to see El Nino happening. El Nino in 2009, anomalies in sea surface temperature. And you can walk around the globe because this is a floating 3D object that is there in front of you. You can pinch, you can rotate, you can see different dates. You can change the theme, you can see the greening and browning of vegetation. So you can travel through time. It's all the superpowers that GIS and remote sensing give us. You can travel in time, you can fly, you can become invisible. All those things are all embedded into this technology. So I call this, I'm with the Center for Geospatial Research, but under the Center for Geospatial Research, I created the Disruptive Geospatial Technologies Lab. So all these technologies are very disruptive. They really change the way we think, the way we manipulate data, the way we collect data. And this afternoon we had an example, and of course, a lot of people working with drones, collecting their own data sets. And again, going back to the point that now we need also to think how we are going to be processing and extracting information from all this stuff. And the disruptive technologies then will help or are helping with all that.
Awesome. Great. So you said currently the hardest part and the most challenging part is processing this data currently, right? That it's been some time that you have like issues for processing the data because they're like getting more in size. And
well, this is all evolving together. We are collecting data, but there are also platforms that allow you to. We are migrating from more local desktop-based to a cloud-based. A lot of opportunities there, and companies seeing these opportunities as or computers that are shared, not just a single desktop sitting on a desk, but computers and resources that are shared and are more powerful, that can process these data more efficiently. And this involves a bunch of different resources. One project I have is, I like scale, spatial scale, but I particularly like temporal scale. So two projects, in fact. One project I have is distributing population, pre-Columbian population in North America. And we are modeling the distribution of this population. This is a very unique thing. We have numbers, estimates of this population, but we don't have a spatial distribution of this population. And this is being done by decade, starting in the 1400s, and then going until end of 1790. And the way you do this, because data sets are so huge, one single image of this data set, one variable that we are processing, because this is all done through modeling, one variable is 1.5 terabytes. This is one single, and we have 80 of those. So, and the variable is basically an image. So one image is 1.5 terabytes. So if you think about processing data and resources we need, when we reach that point, it cannot be local, or it cannot be desktop anymore. So I'm using Google Earth Engine to do that. Well, it happens that Google also has its limits, at least to what they make available to people. And even after negotiations and even after conversations with Google, when they bumped quota and limits that were removed, at least, it's more flexible now for us, because we try to show them how important this work was. Still, I had a process that was took 13, it failed because of internal error after 13 days. And this is Google doing it, not my desktop. So the challenges of processing these data sets. Another thing we have is we are recreating Athens, again, going back to the idea of processing time, particularly one neighborhood in Athens, Cobham, in the 1850s. So I fly historical houses. So if you know TR Cobb House, I flew TR Cobb House, Calpins, a few Taylor Grady. We create a 3D model, and then we create that landscape in the 1850s. And that uses GIS to place the houses, and it's very game-like, because these days everything is blending. You have your ArcGIS, but you also have game engines that have some of the functionalities, or create very photorealistic products that you can then navigate. You can go there, you have an immersive type of experience, and that's exactly what we are doing.
Great, thank you. So I see a question here. They're asking, what is Google Earth Engine and how is it different from Google Earth? The difference between Google Earth and the Google Earth Engine.
Good question. Yeah, because you talk to folks that mention Google Earth Engine. Do you know Google Earth Engine? Have you heard about it? And they'll say, yeah, I played with Google Earth a lot. But they are not the same thing. Google Earth Engine gives you access to the API, or the programming interface, that allows you to access Google servers and process your data. And this is petabytes and petabytes. So we've just mentioned terabytes, 1.5 terabytes for one particular variable. Google has petabytes following terabytes. You have petabytes. So they have petabytes and petabytes of data, including all the Landsat, series, MODIs, and if you're familiar with all these different data sets, satellites, and also physical variables that come from other sources, climate variables, and surfaces, meaning images, and census data, vector data, some vector data as well. So what they allow you to do, instead of you downloading the data to your desktop and processing the data locally, and you can imagine downloading the whole thing. And that's what we were doing just a few years ago, downloading the whole thing and processing locally. What they allow you to do is, by scripting, by writing a script. You access the database and ask Google servers. Google servers are doing a lot of stuff, but sometimes they are idling there a little bit, and they do have a few resources that they can throw and you can use to process your data set. So there are a lot of works. I do have one particular work is GIS Global. A lot of works going global these days just because Google is allowing that. And the way you have access, so you can Google Earth Engine, and then membership is by invitation. You request an account and you explain why, and they create an account for you, and you have some space so you can store stuff online. You can upload your own data as well, so it doesn't need to be just what Google provides. And what Google is doing is in fact interfacing with the federal agencies and data providers, and they are collecting all these different data sets and making available to the community, scientific community and companies. It is all free.
Yeah, just to piggyback off that a little bit, they are obviously for academics like us, but also nonprofits, businesses, governments. And I personally use Google Earth Engine in my research. Like Sergio was saying, I actually upload points that I'm interested in a certain area. For instance, I'm looking at Landsat data, and I will ask it, since I don't need to download the whole scene, I just have, 3,000 points that I want to look at. I upload that shapefile into Google Earth Engine. I request 7 years of Landsat 8 data, and then it pulls it back to me. And you could also do a variety of different things in your code for Google Earth Engine, like filter for clouds, things like that for satellite imagery, which I found super useful. So you don't have to take the time and the space on your computer to have that data stored. You just I get a CSV file with the data I need already filtered, ready to go.
Mm-hmm. Yeah. And that's also a great point about the code you create and process the data. This is also, besides being a platform for you to process your data, it's also a community. So what is happening is that the code I create, I can make my code available to other people, and that code can be reused. So I don't need to reinvent the wheel. There is a lot of things already there, all the classifications. If you go take a class in remote sensing, you're going to learn about supervised classification. You're going to learn about filtering. You're going to learn about all sorts of different things. These all have been implemented, and they are.
Well, thank you. So I was just wondering, what's the programming language that you use for coding about this stuff for like processing and using this file?
You have two. For Google Earth in particular, you have two: JavaScript, and that is done. You don't need more than a browser for that.
Yeah.
You can process the whole planet from your phone. So JavaScript, that is it. And Python, if you want to have a more desktop based and play with a few different things.
All
but
right.
what they call the playground is JavaScript.
Okay, thank you. So Caroline, could you please tell me more specifically, what kind of data you collect in Imagery, and what kind of data do you use?
Yeah, sure. So, like I said, I use Landsat data a lot for my research, specifically Landsat 8 at the moment. I'm using the multispectral imagery. So I basically get a CSV file from Google Earth Engine that has bands, 1 through 11, 12, and then I have that band data there. I also in the past have used Worldview 2 imagery, not related to Google Earth Engine at all, but for a different type of analysis. We also use MODIS data. And so these are just a variety of different spatial resolution data. So the Worldview data is going to be that really high resolution, not drones, but pretty close, a 1.24 meter resolution for Worldview 3. And then Landsat is going to be that 30 by 30 meters, so more of a moderate, medium or low to moderate resolution, or sorry, high to moderate resolution. And then MODIS would be kind of that more truly moderate resolution, so anywhere from 1 kilometer to 250 meters per pixel.
Thank you. So you mentioned drone in your speech. I was just wondering what drone classes are offered for students to register for. Dr. Lowe, I can go ahead.
I teach a drone course in the spring. It is FANR 5640, 7640. Oh, now I said that out loud, but it is 5640, 7640.
That's okay.
But it starts off being fun. I mean, you see a drone floating around in the sky and everybody goes, wow, look at that. But then you sit down and you look at the photos and you can start pointing out things that you had to, spend 10 minutes tracking through the field to go look at with your eyes. And the students, one of the applications that the forestry students have to do is a seedling survival count. So the traditional way is you locate spots in a recently planted pine stand. You walk through the recently planted pine stand and you measure or you count all of the trees, maybe in a 1/50th acre plot. And it's okay now in November when it's 60 degrees outside, but in the middle of the summer, it's 110 degrees and there's gnats. And but one of the applications that we do in the class is a seedling survival count using the drones. So you fly over the site and you insert your plot and you count. And it starts off as oh cool, it's drones, and hopefully with minor heartache it turns into wow, look at this application.
Perfect. So is this the course that is offered on like each semester or just in a specific semester because of the problems you mentioned?
It's only offered in the spring, and I'm Googling
just
it
a spring
just to make sure.
Okay. Thank you. That's okay. So could you please talk about what type of jobs are possible for a drone pilot?
Me? Sure. In the natural resources, I see drones positioned as allowing field workers to do what they have to do, but more efficiently. So there might be a handful of new jobs, the drone guy, but hopefully we are focusing on graduating students with the technical skills in forestry or wildlife or fisheries, but also with a couple of extra tools. They know how to use a GPS unit. They also have experience flying a drone and applying that information to what they are expected to do anyway. Hopefully allowing them to be more efficient in their in their job.
Yeah.
And I can kind of testify to that, being a PhD student. On one of our projects, we don't have anyone that's certified FFA to fly a drone, but we do have a small drone that we could fly like Lowe locally. And if we had a larger drone, or if we had someone who was able, like a researcher, for example, who was FFA certified to come into the field with us, because I do work in coastal wetlands. And so having someone who is qualified with these kind of skills in the field would be extremely useful. So we weren't able to get quality imagery from our small drone flight, but if we did have a researcher out there that was qualified, it would have been really good for our research.
So it's important for drone pilots to take this FFA drone exam, right?
If you want to be a commercial pilot, if you want to make money, if you're going to be compensated, you need to be certified. I would say also it's because the applications it's basically limitless. The applications of the technology. We have people who left geography and went to work for the Department of Transportation in Nevada, if I'm not mistaken. And he was exposed to drones here. And that wasn't his main thing. He was trying to find landmines. Tripp knows what I'm talking about.
I do.
Yeah. So Drew Knight. And is that Nevada?
I think
is that
so.
right here? Yeah. And that wasn't exactly his expertise. I mean, he didn't study transportation, but that particular skill gave him the job. And a lot of people paying more attention to drones. And of course, this has already been mentioned. It's not just the drones. I mean, if you bring more knowledge and you know how to link that bird eyes view there, seeing from above, to what you see from the ground and explain things, then it becomes an extremely powerful tool. You just increases your chances of getting a job if you can just the knowledge and the capability and the potential just increases the chance of you getting a job.
Absolutely.
Having said that, you don't necessarily need to fly a drone to be a pilot, or it's an interesting relationship there. You become a remote pilot in command when you take the test and pass the test. You're certified, but that doesn't mean you are the person flying. And it may happen that somebody else has the skills to fly and you don't, but you're the person responsible for the operation. That's how FAA sees it. You're not not necessarily you're the most skillful pilot. So there is a difference there in terms of getting the certification and really flying a drone. Usually the person who gets the certification also likes to fly it. Got the certification because there is also a personal choice there. It's not just fun. But and it's a lot of fun.
Yes.
Yes.
So it kind of shows like qualification for anybody who likes to become like more better pilot, or be like more I don't know, practical in the field that they're working at. So I have a question from everyone here, and that's, what are the challenges in collecting this data for from drones actually? Can you give it more more specification, getting more details?
Mm-hmm.
I can give a brief challenge, and then maybe Tripp and Sergio can kind of comment on this. But specifically in wetlands, it is a very homogeneous environment for the most part, and so you have to really worry about being able to have those tie points in the marsh to knit your images together. And so we've ran into issues when we're trying to fly over a marsh that is very homogeneous, that doesn't have those points that you need to be able to tie the images together. And it just comes out very blurry. Also, you have to worry about the glint of the sun. So in, like, again, I said, in our coastal wetlands, you might have little pools or ponds. And so depending on what time of the day, that sun glint can absolutely ruin your imagery.
Mm-hmm.
So,
So
Yeah.
the data that you're working with is kind of just for images, or that's it, or you can get data in other versions, other types as well too?
That's a good point, because in this afternoon, if you the video was recorded, the presentation, the demo there was recorded, and we talked about multispectral sensors. We talked about possibilities when you go equip your drone and go collect data. One possibility is just your common camera, much like a phone, duct taped. Yeah, exactly. Yeah. So Tripp was showing a multispectral sensor there, and that's the MX.
It's the M.
The M.
Yeah.
And so that is a Mica sense. What it's a thermal. It's a FLIR.
Yeah, that's thermal.
Yeah.
Yeah.
So one of the things I just mentioned, the superpowers, you can fly, you can become invisible. you can time travel, and you can also see beyond visible. You can see things that nobody else sees. I made a presentation at an elementary school once, and I mentioned I had this little figure, the super guy who does remote sensing. And after I just mentioned that, a student raised his hand and asked if we can see ghosts using our sensors. And but we usually don't. But you can see beyond visible. You have thermal cameras. You have a full sort of options from sensors that have wide bands, and you have just a few bands. Maybe what Tripp just showed is similar to what I flew this afternoon, 5 bands. It can see in red, green, blue, near infrared in a part of the spectrum we call red edge. That's it. But there are systems that have very narrow bands, and they can see hundreds of bands. And in fact, I worked with one that had thousands of bands. And then you have things like the thermal sensor. So that it becomes, we talked about being flooded by data. It's not just seeing it for pretty pictures, but it becomes quantitative because those are instruments. Those are measuring. Those are not just collecting photos. Those are instruments that are calibrated instruments. They are measuring quantities. And you can then, that's why you can establish relationships between what you get from the image and whatever you measure using something else in the field. And that's why also, because now you have all these different layers of data, you are flooded by data management became a problem, a challenge, I guess. So when you mentioned challenges with drones, there are many. There are, this is all technology, all evolving. Chances of things not going exactly right as expected when you are in the field, and with much less resources than you have in the office, they are kind of high. There's always a chance that something's going to go wrong, and there's going to be property damage, or you're going to lose your drone that costs $10,000. Look at that.
This is a prop from a drone after it spent a week in the marsh in South.
What is it called? Sorry.
This is a propeller from a wrecked drone that I keep around to remind myself not to do something stupid.
And it's a big concern too. Like if you're in the field and let's say you only have, 3 days to be in the marsh and all of those days are windy, it's very difficult to fly that drone in a safe manner so that you don't lose it and that you get appropriate data. And I know that it's a variety of different places that you can fly drones to get really good imagery depending on your application. But thinking about marshes, yes, the fear of it sinking into the mud and never returning is real.
Right.
One of the challenges that we face is we have the drone imagery from above. Our new aquatic drone is collecting data below the surface. So we have these 2 different data sets, each with information that, that we really haven't had access to. 5 years ago, we wouldn't have been able to even consider doing this. But we have information from 2 different sources. How in the world do we align those different sources in space? If we're using the GPS on our telephone, we might be within 15, 20, 25 feet, and that's not that's not good enough when we're dealing with drone data with resolutions of centimeters. So one of the challenges we are facing right now is using I set out some props for today, using a high accuracy GPS unit to tie together the drone information with that data from the aquatic drone. And it's a lot of geometry. So any kid out there wondering why they have to sit in this geometry class, this is why, and all of this is why they need to at least understand, you know, the well, Sakatoa, and I will leave it. You know, triangles are wonderful. So.
And to kind of go off of that a little bit further, I work with the LTER a little bit on Sapelo Island, and so we did a study at the beginning of last summer in July and August, I think, where they bought a new drone. We were so excited to get it flown, but in order to get it flown and have good imagery for a disturbance project that they're working on, we actually had to go and place ground control points in the marsh. And so it does take a lot of time, a lot of planning. We had basically all hands on deck, a huge team that came out to go out and put all of these points into the marsh. We had to take a Trimble to make sure that we had exact GPS points of those ground control points, and then flew the drone, hoping that, you know, nothing else is going to be interfering with the signal. Thankfully, it was successful, and we still have drone flights there today, but it takes a lot of work and a lot of planning.
Yeah, it's a hard job. I wonder, this data that you're collecting and using for processing your models or whatever, for what's the range that these data belong to? I mean, they belong to, for example, this year and last year, or older than that. The data that you're using, could you please say that they belong to how long ago? And
right. So for drones, and we're talking about flying drones and copters or fixed wing or airplanes. But depending on how long you want to go, how far back you want to go, folks were flying something similar in terms of airplanes, hobbyists, usually with the help of hobbyists, and also blimps. So images from above, and of course, we in geography, we have a tradition in air photo. A lot of work. In fact, the drone is bringing back something that people thought that somehow orbital systems replaced. When resolution images, some folks thought, well, that's all we need, and it's so expensive to hire people to go fly an airplane over a particular area, and all the complications, and satellites going to provide us this data, and that's enough. And the drones, and there's an art or science, photogrammetry and remote sensing together. The idea of extracting information and measuring from photos, from images. This was traditionally done with air photos, and now we do that with drones. So all this, again, because I mentioned the empowerment, all this empowering us allow us to proceed. So if you go back and think about data, we do have stuff that people did with blimps, and they can go back in time. Landsat was just mentioned. Caroline mentioned she uses Landsat. The first Landsat was launched in 1972. So that is not a drone, it's orbital, but it's a time series of data that allows us to, and with the ones we usually use, the first, which is Landsat 5, 1984. And anyway, it's a long time series, and you can do a lot of work, particularly capturing the dynamics of areas, how these areas are changing, population growth or deforestation. This is what is being used and has been used to estimate deforestation in the tropics. These systems, because of continuity, because of the availability of these systems. For drones specifically, I started working with them in 2013. So
like
that
8
would be,
years ago.
Just to throw in a quick fact, really quick, the first air photo was taken in 1858. So
mhm.
a long time, a very long
Yeah.
history of air photography.
Yeah.
Right.
Nadir, Nadir, or
Nader.
Nadar. Yeah, yeah.
Yep. Nader.
France. Yeah.
So I can see students that ask a question. The question is about the types of the sensors that you just talked about them for collecting the different data. Could you please elaborate more and what, like talking about different types and what is the benefit of using one sensor over another one, if there are any, or you choose them based on what?
Mhm, mhm.
We-
Tripp has the prop there, so he's gonna.
I have the camera. There, we have an example in a couple of my class, and it is FANR 5640 7640. I had to get that out there. It, but we have a regenerating site out at our Whitehall Forest. So the pine trees might be 4 or 5 years old, and I flew over the site with the color camera, and during the summertime, and this was actually one of my first flights, and I was so excited to get it back in the office and look at the photos, because I'm thinking, you know, I can see the pine trees. Let's go out and do something with it. So I got the data, put it on the computer, and you know, I looked at the ortho photo I created, and everything was green. Pine trees were green. All of the sweet gums growing next to the pine trees were green. The grass was green, and it was really frustrating. So I went out with the multispectral camera and flew the site again, thinking, well, maybe this will help tuss out the difference between the pine trees and all of the hardwoods. And the information was a little bit better. I could look at the data and you know, visually point out, you know, that's a pine tree and that's not a pine tree. But what really sealed the deal is when I repeated the flight during the winter time. And I flew the site with the color camera. Then I flew the site again with the multispectral camera. And, you know, the timing of the year makes, I think, just as big a difference as the actual sensor you use. Because the winter image from the multispectral image, the pine seedlings were bright white, and they were sitting there hollering, "Hey, I'm a pine seedling," and everything else was dead or looked brown. So you know, that was really the first you know, the first time it dawned on me, it's not just the sensor, it is you know, when you fly it and actually how you fly it. This thermal camera, we had a student doing a project, and it was supposed to start off with, I wonder if you can do that. And he wanted to use these thermal cameras to do an inventory of nesting birds in an urban area. So we went out and hid some of those hand warmers that you crunch up to keep your hands warm, and threw those in the woods and flew this over the site. And those little bright hand warmer, or those hot hand warmers, were little white beacons just kind of, you know, scattered throughout the forest. So you certainly have to match up the sensor for your application. You know, this camera certainly wouldn't see those hot hand warmers, but you also need to consider when you're going to go out and fly as well.
Mhm.
And just to add on to that, I since I'm more of a satellite data person, I think scale really matters. And so it depends on the project that you're working on and what applications you want to have. So if you're looking at a landscape level, a large area, you're not going to want a drone necessarily to analyze that area, because you're not going to see those larger patterns that you're looking for. But for example, if I was going to use Landsat to count pine trees, it's not gonna work. So in that case, I would definitely need a different type of sensor, a different type of spatial scale. So really tailoring what your project is to the imagery that you're using is very, very important.
Mm-hmm. And you know, that's a great point also, because one thing that people have been trying to do for a while in remote sensing and different levels of success is to connect levels of acquisition. As Caroline just mentioned, you cannot fly a drone over, let's say, a whole state. It's not going to be possible. But the satellite will be able to collect data for the entire state, or for the entire country, or for the entire continent. So you need to be able to link what you can extract from the drone to what the satellite sees. So, and that is the scaling up. That is holy grail of remote sensing. It is being able to scale up, and everybody wants that. If you can explain what the satellite sees, and that makes not just explain in terms of, oh, it's seeing a tree, but you could say perhaps this tree is healthy, or the amount of biomass you have there, and you become more quantitative. If you can do that, then that is extremely powerful, because that it will help not only explain the present, but predict the future based on expected change.
Exactly. And that's exactly what we're working on with my project. It's looking at blue carbon, so carbon stored in coastal wetlands. And if we can scale how much we know that the wetlands are taking in carbon, it can have major effects for climate change and understanding the carbon cycle in our world. So Sergio, I think you're 100% right. That application, that link between small scale or like close to the ground, very accurate information to satellite data, but that jump is very hard.
Yeah, this is the first time in my life I'm 100% right.
And it's recorded.
It's recorded, yeah.
All right, thank you. So now I think we can open up the floor for questions.
I had a quick question for the drone users in the room. How can students have access to collecting drone data through campus resources?
Okay. Our students here at Warnell, I require them to acquire the Part 107 certification. And then also they have to go out with me and fly and convince me that they can fly safely before I allow them to take the drone out themselves. I have flown drones for students here on campus in Atlanta, you know, several, you know, down in Savannah, you know, for those instances where, you know, that wasn't possible. But there is a certain level of responsibility that has to be adhered to when you're flying a drone. And that is extremely important, that when you are out flying, that you're flying safely.
Yeah, I call that you, and I had mentioned that to you, Austin. You people need to earn their wings, and that's what the common terminology, I guess, applied to other areas, but earn their wings, and that means you observe. We who have access to drones, or the drones came through us because we submitted the proposal, and the sponsor is paying for the drone. So we are the keepers or the maintainers. We are the folks who are responsible for that, not just not just property, but we cannot just hand people a car if they don't know how to drive, and end up harming people and damaging property. So there's a responsibility on that side as well. I had students, we just mentioned the example, Drew. He was flying $10,000 piece of equipment, and he went out with me. He learned how to fly. I saw he was responsible, and I saw that he knew what he was doing. He was following procedures and getting ready to fly, not just, okay, let's get the drone and see what's going to happen in the field. Learning how it works, very important. Being ready for the unexpected, because the unexpected will happen. So really being ready. So I was okay with that. So okay, can I fly? Sure, it's here. Go fly, be happy, collect data. I also had a student who asked me if she could borrow the drone, and say, okay, show me how much you know. She didn't know, and say, okay, you're not ready. I'm sorry, you cannot go by yourself. She didn't like much, but that's the reality. And again, it's a responsibility we have. I mentioned this afternoon, one flight next to Hartsfield International. We are used to flying. Okay, but then you're gonna fly at a location where if something goes wrong, the stakes are this high. So you try to be the safest you can, check everything 5 times, and then you add $1 million insurance on top of that, and that's what I did. So you're flying FAA according to the rules and with insurance, and you try to stay current. Because a drone pilot is not, we are merging fields here. We are domain specialists because we try to understand the application, vegetation, or soil, or marshes, and we are also engineers. We are assembling stuff, disassembling, integrating, learning how they work, the inner workings of how this thing operates and when things go wrong, and they will, then we can try and fix them in the field. I see Marguerite, she is there. Marguerite has a photo of us measuring the weight. A drone was misbehaving, made a, yeah.
I know what you're talking about.
We made a scale at Sapelo Island, at a cabin at Sapelo, out of spoon kitchens and kitchen spoons and rocks and a grocery bag, but just to trying to find what the problem was. And all that to say, there is a lot of things involved in flying the drone, and we are observing behavior. Meaning, if the student wants to fly, I'm the first one saying, okay, you should try it. Go. It's a resource. In fact, I always say that as well. Most of these drones are being paid by you anyway, because it's tax fee money. So you students are paying for that. You should have access to them, but you need to earn your wings.
And I'll just say that was a great example of, you flew a lot. You tested it, everything worked. We brought it out there, and you brought it up, and it would not come down. And so it's like, but it's you have to run into these unexpected, terrifying moments, I guess, and you have to have a few of those to kind of get over. And I just want to say real quick, because I think you have to go to the next session. There's a great club, I guess, or society that you can join, the Academy of Model Aeronautics. It sounds really, like intimidating, AMA, but really it's hobbyists who fly drones, and is really inexpensive to join. It gives you insurance if you're a member, if you are flying as a hobbyist. It keeps you current with especially legislation that's changing and affecting people who fly as a hobby. And I would recommend do the 3-year membership, and then you've got it. You've got some some insurance and a body of people you can kind of look to if you have questions.
Right.
So
I think
I'm
that's a
going to
good
put that in
point
the
because-
chat.
Great point also, Marguerite, because Tripp, how is this? Is Michael Lucas work for the drone group? Or do we still have that?
We do. We've been sidelined with the COVID. You know, with the whole, you know, everybody's sidelined. But yes, we do have a drone user group on the University of Georgia campus. Look for an email in your inbox soon, and we'll get something out. But there is a lot of drone. There are a lot of opportunities on campus if you're a student to get practice with the drone, or if you're a researcher to you know, to have imagery or have data collected by drone.
Mm-hmm.
Thank you. And if there are no more questions, all right, I don't see any question. Thank you everyone for giving us your time. This panel session was great. I appreciate your valuable information. We have run out of time a little bit, so I'm going to hand it over to Austin for the next presentation. And thank you again.
Thank you.
Okay.